we're going to go over finding some derivatives of exponential and logarithmic functions. And this is a very short lesson. It's actually a lesson that I did not do last year with my students because the likelihood of seeing a ton of this is low. And it's really just very much about, do you have the formulas memorized? So we're going to go through some of these again with the formula quiz / test, whatever you want to call it. Right, that's really going to be the key thing to have yourself in a position to be successful on these. So you got your objectives here: finding derivatives of exponential functions, log functions, and then using log differentiation to determine the derivative of a function. So these are the two main formulas I'll be using in this lesson. So this one here, which has the derivative of a natural exponential function, is you just copy it first. So e raised to whatever power, and then think of it as like the chain rule, take the derivative of whatever is in that exponent. For the natural logarithm function, all right, whenever I see the natural log of some function, I'm going to go 1 over that function that's my argument, and then kind of like the chain rule again, take the derivative of that function that is my argument. Okay, that's how I'm going to kind of approach these two types of problems. All right, so let's see this first one here. This is a derivative of the natural exponential function. So I'm going to do f prime of x is going to be d dx of this whole thing. Okay, so the first thing I always tell students is copy it down. So you have e to the tangent of 2x times the derivative of the tangent of 2x. So again, just copy it down. Hopefully we remember now. If you are looking at this after taking the quiz, or even before you're taking that quiz over the formulas, right? We need to know that the tangent, the derivative of tangent, is secant squared. All right. So again, we've done the chain rule. So you're going to do secant squared times 2x, but then times, right, the derivative of that inside function of 2x. All right. So all of this is going to eventually become, all right, so right now I'm just copying everything, but then times the derivative of 2x, which is 2. In terms of like how you should write this for your derivative of your f of x function, really I'll just defer to whatever in the AP exam has, simplified. What I usually do is I usually put the constants first. So personally, I would write this as the derivative of f of x is equal to 2 times e raised to the tangent of the 2x power times secant squared 2x. And I would leave it like that. All right, so that's kind of the process for the derivative of a natural exponential function. Okay, let's do the same idea, but we're going to use some rules from one of the first lessons, our lesson on 3.3 called differentiation rules, because I'm going to be using the quotient rule here. Okay, so to find the derivative of y, I'm going to do d dx of e to the power of x squared times the original denominator x minus the derivative of the denominator times the original numerator, all over our denominator squared. Now, again, I'm trying to show all my steps so you can hopefully watch this video and learn a little bit about how to do this. But again, when you're doing your IXL links, when you're doing the tests that has the multiple choice questions, again, show as much or as little work as you want to, right? I'm not taking the time to show you what my brain is thinking. I'm just going straight into taking derivatives. Okay, so the derivative of e to the x squared, let's see if you can do this a little bit faster. You're going to copy it down, and then the derivative of x squared is 2x. Don't forget to multiply that by the original x, our original denominator, okay, minus the derivative of x is just 1 times e to the power of x squared all over x squared. All right, so I'm just going to clean it up a little bit. You'll notice that in the numerator, I actually have e to the power of x squared, which is a common factor in both of those. So I'm just going to factor it out to make it look a little nicer. All right, times. Then I'm going to multiply these 2x and x to get 2x squared, and then minus 1 all over x squared. So that's it for the derivative of this rational function using that quotient rule. All right, let's switch to this idea of taking the natural log of a function and find the derivative of it. So again, the way that I want you to think of this is that if you see the natural log of some big argument, in this case we have a cubic trinomial, I'm going to first do 1 over that argument, which is x cubed plus 3x minus 4. Let's try that again. All right, and then I'm going to multiply that by the derivative of x cubed plus 3x minus 4. All right, so I still have, I'm going to copy this down, 1 over that polynomial, 1 over x cubed plus 3x minus 4, and then times, and the derivative of x cubed is 3x squared, and the derivative of 3x is 3, and the derivative of minus 4 is 0. All right, so to end up writing this as my solution or my answer, I'm just going to put that derivative 3x squared plus 3 in the numerator. Okay, and so that's it. That's one of the more basic ways that you could do this. We have one more example to do where I'm going to show you how to, you could do what we did on the last one and do like 1 over this giant argument and then find the derivative. But if you do that, you're going to have to use the quotient rule, and you'll also have to end up using kind of the chain rule. So what I would recommend doing is you can actually use these properties of logs that you learn in Algebra 2 and reviewed in pre-calculus to make this a little bit simpler. So I'm actually going to go back to your understanding of that first. So if you look at in the numerator, right, in the numerator I have x squared times the sine of x. So if I were to break that up, I can write the natural log of x squared plus the natural log of the sine of x. All right, so breaking it up by giving them their own logarithms. And then if you look at the denominator, you've got 2x plus 1. And if you remember from how to expand that from last year or the year before, you're going to subtract the natural log of 2x plus 1. Okay, so now if I go ahead and do the derivative here, right, the way this is going to be 1 over x squared times the derivative of x squared, which is 2x, plus 1 over the sine of x times the derivative of the sine of x, which is cosine of x. All right, hopefully you have that memorized already. Minus 1 over 2x plus 1 times the derivative of 2x plus 1, which is just going to be times 2. Okay, so if I clean that up a little bit, I have 2x over x squared plus cosine of x over the sine of x minus 2 over 2x plus 1. And this is the answer. I'll go ahead and simplify it one more step just because, you should be able to keep going if you wanted to, but, I'm okay if you just want to leave it like this. But essentially, 2x over x squared is just going to be 2 over x. If you remember from your days in trig, cosine over sine is cotangent of x. If you remember, the sine over cosine is tangent, so if you flip that, it's cotangent. And then I'm not going to do anything with this last one. That's just going to say minus 2 over 2x plus 1. So that's it for kind of expanding first using your properties and then making your derivatives of each of those a little bit simpler to do. Okay, so go ahead and try the homework. Don't forget to try the IXL links, and hopefully you'll be ready for the test in about a week or two.